When a pump controller is service entrance rated and located directly after the utility pad mount transformer and current transformer cabinet with a meter, the question arises whether an additional disconnect is required. The National Electrical Code, or NEC, provides specific guidelines to address this situation. A service entrance essentially defines the point where the utility's electrical supply connects to the building or structure's internal wiring system. Equipment that is service entrance rated is designed and tested to meet stringent standards for handling the incoming electrical service. These ratings ensure the equipment can safely manage the available fault current and withstand environmental conditions at the service entrance. According to the NEC, a service disconnect is generally required to provide a means of cutting off all power to the building or structure. This disconnect serves as a critical safety feature, allowing for de-energization during maintenance, repairs, or emergencies. However, the need for an additional disconnect when a service entrance rated pump controller is already in place depends on several factors, and specifically on the arrangement and accessibility of the components. Firstly, consider NEC section 230.70. A1, which states that the service disconnecting means shall be installed at a readily accessible location either outside of a building or structure or inside nearest the point of entrance of the service conductors. This means that the primary service disconnect must be easily reachable for quick operation. Secondly, if the service entrance rated pump controller is located immediately after the meter and is readily accessible, it can serve as the main service disconnect, provided it meets all the requirements outlined in NEC Article 230. Specifically, Section 230.70. A3 states that the service disconnecting means must be suitable for use as service equipment. This suitability includes being properly rated for the available fault current and being capable of being locked in the open position, as detailed in Section 230.70. D. Thirdly, the term readily accessible is defined in Article 100 of the NEC as capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. If the pump controller location fulfills this definition and it is capable of being locked in the open position, an additional disconnect may not be necessary. Fourthly, if the pump controller is not readily accessible, for example, if it is located in a locked room or behind other equipment that would impede quick access, an additional service disconnect must be installed at a readily accessible location. Fifthly, it's important to verify that the pump controller's service entrance rating is adequate for the available fault current at the service. The available fault current is the maximum current that could flow during a short circuit condition. This value must be determined through an engineering study, often performed by the utility or a qualified electrical engineer. The service entrance equipment, including the pump controller, must have a short circuit current rating, or SCCR, equal to or greater than the available fault current. This ensures that the equipment can safely interrupt the fault current without failing catastrophically. Sixthly, NEC section 110.9 addresses interrupting rating. Equipment intended to interrupt current at fault level shall have an interrupting rating sufficient for the nominal circuit voltage and the current that is available at the line terminals of the equipment. Equipment intended to interrupt current at other than fault level shall have an interrupting rating at nominal circuit voltage sufficient for the current that must be interrupted. Seventhly, NEC section 110.10 addresses circuit impedance, short circuit current ratings, and other characteristics. The overcurrent protective devices, the total impedance, the component short circuit current ratings, and other characteristics of the circuit to be protected shall be selected and coordinated to permit the circuit protective devices used to clear a fault to do so without extensive damage to the electrical equipment. This fault shall be assumed to be either between two or more of the circuit conductors, or between any circuit conductor and the equipment grounding conductor or equipment grounding bus of the supply system. Eighthly, local amendments to the NEC can sometimes introduce additional requirements. Municipalities or local jurisdictions may have specific rules or regulations that are stricter than the NEC. Therefore, always check with the local electrical inspector or authority having jurisdiction or urge to confirm any local requirements that may affect the installation. Ninthly, the arrangement of the current transformer, or CT, cabinet and meter between the utility pad mount and the pump controller does not inherently necessitate an additional disconnect, provided the pump controller meets the NEC requirements for service disconnect and is readily accessible. The CT cabinet and meter are typically part of the metering equipment and do not function as a service disconnect. Tenthly, consider the specific requirements for overcurrent protection. The service conductors must be protected by overcurrent devices, such as fuses or circuit breakers, sized appropriately for the conductor ampacity. The pump controller may incorporate these overcurrent devices, or they may be provided in a separate enclosure. In either case, the overcurrent protection must comply with NEC Article 240, which covers the protection of conductors and equipment against overcurrent. 11thly, it's important to ensure that all equipment is properly labeled and identified. The service disconnect, whether it is the pump controller itself or a separate disconnect, must be clearly labeled to indicate its purpose and function. This labeling helps to ensure that individuals working on the electrical system can quickly identify and operate the disconnect in an emergency. 12thly, the pump controller must be suitable for the environmental conditions at its location. If the controller is installed outdoors or in a damp or corrosive environment, it must be rated for those conditions. This may require the use of an M3R, 4, or 4X enclosure, depending on the severity of the environment. 13thly, proper grounding and bonding are essential for electrical safety. The service entrance equipment, including the pump controller, must be properly grounded to the grounding electrode system. This grounding system provides a low impedance path for fault current to return to the source, helping to trip over current devices and prevent electrical shock hazards. Bonding ensures that all metallic parts of the electrical system are electrically connected, further reducing the risk of shock. 14thly, the selection and installation of the service entrance conductors must comply with NEC Article 310, which covers conductors for general wiring. The conductors must be sized appropriately for the load they will carry, and they must be installed in accordance with the NEC requirements for conduit, cable, or other wiring methods. 15thly, maintenance and periodic inspections are crucial for ensuring the continued safe and reliable operation of the electrical system. Regularly inspect the service entrance equipment, including the pump controller and disconnects, for any signs of damage, corrosion, or overheating. Perform routine testing of the overcurrent devices to verify that they are functioning properly. 16thly, the use of surge protective devices, or SPDs, at the service entrance can help to protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. SPD should be selected and installed in accordance with NEC Article 285. 17thly, consider coordination studies. In complex electrical systems, a coordination study may be necessary to ensure that the overcurrent devices are properly coordinated to minimize the extent of any power outages. A coordination study involves analyzing the time current characteristics of all overcurrent devices in the system to ensure that the device closest to the fault will trip first, while upstream devices remain closed to maintain power to other parts of the system. 18thly, arc flash hazard analysis should be performed. An arc flash is a dangerous electrical explosion that can occur during a short circuit. An arc flash hazard analysis is a study that determines the potential arc flash hazards at various points in the electrical system. The results of this analysis can be used to select appropriate personal protective equipment, or PPE, for workers who may be exposed to arc flash hazards. 19thly, if the pump controller includes motor control components, such as variable frequency drives, or VFDs, ensure that these components comply with NEC Article 430, which covers motors, motor circuits, and controllers. 20thly, if the pump controller is part of an emergency or standby power system, ensure that it complies with NEC Article 700 or 701, respectively. These articles provide requirements for the installation and operation of emergency and standby power systems. In summary, whether an additional disconnect is required for a service entrance rated pump controller located after the utility meter depends on several factors, including the controller's accessibility, its suitability for use as service equipment, the available fault current, and any local amendments to the NEC. Always consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and standards.